Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and we're going to be talking about mixing for one more time, okay? Just going to be sharing it with you in a slightly different way. Again, what we've been talking about is the depth that the atmosphere is well mixed. And during the winter season, those mixing depths are not that high because the sun is fairly weak. But as you head deeper into the spring and especially the summer, you can have mixing depths that exceed 5,000 feet, in some cases maybe even 6,000 or 7,000 feet. So we're going to look at this in a slightly different way today. And so let's get started. My title is One More Day of Mixing It Up. So again, just to refresh your memory, what information do we need to project the surface temperature based on the mixing depth that we expect for that given day? So we need the elevation above sea level of any given point on the map. We need the height above sea level of whatever mixing depth you expect for that day. If you think it's going to mix down from 900 millibars, then you need to know what the 900 millibar temperature is forecast to be. If you think it's going to be 850, you want to know the 850 temp. If it's going to be 700, you want to know the 700 temp. Whatever depth you think is going to be the mixing depth for that day, then you want to know the temperature that is forecast to be at that particular level. Okay, and then the temperature along the constant pressure surface that most closely approximates the mixing depth that you expect, okay? So you need to know the height of that level and also the temperature at that level. And then once you have those three things, you're all set. And remember, the dry adiabatic lapse rate is 9.8 degrees centigrade per kilometer. So basically, when you start at that constant pressure surface, which is the level at which you think the atmosphere is going to become mixed up to that level, then you're just taking that temperature down the dry adiabatic lapse rate, and that translates to about 5.4 degrees per thousand feet, okay, which are units you may be a little bit more familiar with. And then you take that down to whatever the surface is of whatever location you're looking at, and that gives you the projected high for that day. So I took 3 different levels just for fun. I started off at 900 millibars, okay, so if the atmosphere today would have mixed down from 900, then this is what the result would have been according to numerical model forecasts. Now the yellows are 60s, and you can see that it doesn't quite get Raleigh to 60, but we made 66 today. So it mixed down from a little bit above 900 millibars, more than likely, and then you also have the RDU effect, which probably added a degree or two to the temperature. When you look down here at these colors here, these are 70s, the reds are 80s, okay? And then up in here, you have the colder temperatures with 20s and 30s up there. Now, unless the atmosphere is completely dry adiabatic all the way up to whatever level you're looking at, the temperature projections are going to increase as you increase your mixing depth, okay? And so now let's check it out for 800 millibars. Now, if we were to have mixed down from 800 today, we would have gotten past 70 at the RDU airport, and 80s would have been in existence all the way up into southeast Kansas around Wichita. If we would have mixed down from 700 millibars, and that is rare even in the summertime, okay? But this is what would have happened. We would have been in the 80s, and 90s would have been in existence in South Florida, all the way up into parts of Texas and Louisiana. So what actually happened today? Well, this was reality, and you can see the yellow, which indicates 60 or higher, did indeed cover most of North Carolina. And we had the really cold Arctic air way up here in Canada. So what level most closely approximated reality? Well, here they are. This is reality here, and this is 900 millibar mixing depth here. It's not a duplicate, but it's definitely the closest match, much, much closer than the 800 or the 900 or the 800 or the 700 millibar mixing depth. So that's reality. This is the mixing depth at 900 millibars, and again, not an exact match, but pretty darn close. And when you look at the forecast soundings, the mixing depth was forecast to be right around 900 millibars. So it matched up very, very nicely. Now tomorrow, the air mass overall will be warmer, and that will contribute more to the warming tomorrow than anything else. I don't know that the mixing depth is going to be all that much greater tomorrow than it will be today, but the atmosphere will be warmer, and so that should be enough to get us up to the 70-degree mark or slightly higher. All right, I hope that makes sense. That is bonus weather video number 1 for this week. Number 2 will be coming up on Wednesday. a different topic. You're probably thankful for that. And the next daily update, of course, coming up tomorrow. So I hope you have a great Monday evening, and we'll talk to you again tomorrow. Take care, everybody.